so the next type of angle pair we need to learn about is called corresponding angles. The three types of angles we're learning about today, instead of just being two intersecting lines, it's three. So instead of just having one line that intersects another line so that you have angles that are vertical or angles that are adjacent, we're going to have two lines and then another line that's going through them somehow. Okay? So corresponding angles are formed by two lines and another line intersecting them. And that other line that is intersecting is called a transversal. So that's a new vocabulary word for you. The line that's going through the two other lines is called a transversal. Okay, so corresponding angles. How many angles were created when I drew this picture? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, right? 5, 6, 7, 8. Okay. So we created 8 angles. Corresponding angles are in a specific location to be related to each other that way. What it is like, you know how if you have roads and where the roads cross, it's an intersection, and you have 4 corners at the intersection where there might be different things, businesses or houses or something on each corner, right? So maybe if you're giving someone directions on how to get somewhere, you'll say, oh, well, Walmart is on the southwest corner at 62 and 56th, right? Okay? Corresponding angles means that they are in the same related corner, like they're both in the southwest corner, or they're both in the northwest, or they're both in the southeast, or they're both in the northeast. So I'm just going to label 2 corresponding angles on my picture. So I'm going to call that one angle 1, and later I'm going to call this one 2, so I'm going to do this one 3. But angles 1 and 3 are what we call corresponding angles, because they're both, like if you look at that intersection, that little angle right there is in the same corner at this intersection as it is at that intersection, so they correspond to each other. Are there any other pairs of corresponding angles in this picture? Yeah, if we had a little 2 and a 4 written there, then 2 and 4 would be corresponding. Good. What if we did like 5, 6, 7, 8? Then 5 and 7 would correspond, and 6 and 8 would correspond, right? Okay, so there are 4 pairs of corresponding angles. All right, now we're going to learn something about corresponding angles when the lines are parallel. Do these 2 lines look like they could be parallel? Right now, do we know that they are? No, we don't know that they're parallel for sure, even though they look like they might be. Does anyone remember how we mark lines parallel? How do we know when lines are parallel? We usually put a little arrow or triangle in each one. We learned that at one point. And if we put a little arrow, triangle type of thing in each line, that tells us that those lines are parallel. Okay? So now I've told you that the lines are parallel. We have a postulate to learn. Remember how a postulate is a statement about something in geometry or other math that is obviously true. Okay, our postulate says if the lines are parallel, then the corresponding angles are congruent. Yeah. Yeah. Okay, if the lines are parallel, then the corresponding angles are congruent. So what does that tell us about angle 1 and angle 3? the same. So I can say angle 1 is congruent to angle 3, or I could say the measure of angle 1 is equal to the measure of angle 3, right? They're the same measurement. I should have made my picture a little bit smaller so I had more room to write. Okay. Next. The next type of angle pairs we're going to learn about are called alternate interior angles. Okay, same starting property. They are formed by two lines and a transversal, because a transversal is a line that crosses through those lines. So let's draw our picture again. Alright, notice the word interior. Interior usually means what? Inside. Is there a part of this picture that we've drawn that is more inside and part of it that's more outside? Where do you think would be considered inside? This to me seems outside, and in here seems like it's inside because it's between the two lines. Does that sound logical? Okay, so when we're talking about interior, we're talking about angles in here. Okay, now here's the other important detail, alternate. What does the word alternate mean? If you have an alternate in a sports event, you have someone that's going to change in for someone else, right? Or sometimes alternate means opposite, like, or alternating current, that is our electricity source. The current changes directions, so it goes opposite directions. Okay, so if we're talking about angles that are inside but opposite, that means they're going to be on opposite sides of that transversal. So this was angle 3. So this was 1, 2, 3, 4, 5, 6. So see how angles 6 and 3 are on opposite sides from each other on the inside? That is called alternate interior. There's also such a thing as alternate exterior, but we're not going to write that down. There's not actually a postulate for that or a theorem for that, but it still works. Okay. Here's the theorem that we need to know. The theorem says if the lines are parallel, then alternate interior angles are congruent again. They're going to be the same size. Notice how in our picture both 6 and 3 are obtuse angles, right? So angle 6 is going to be congruent to angle 3. Is there another pair of alternate interior angles in this picture that I haven't labeled? Yeah, 7 and 2 would be another pair of alternate interior angles. Good job. So there's two pairs of alternate interiors. And then there's two pairs of alternate exteriors, which are also going to be congruent to each other. We're not going to write that down, though, because we don't really have enough room. I did forget, though, to show that my lines are parallel. Now, do the lines have to be parallel? They only have to be parallel if we want to know that the angles are congruent. If we have lines that aren't parallel, we still have these different angle pairs. They're just not congruent, and the next one we're going to talk about is supplementary. Okay, are you guys done with these two pages? Next page. The last one we're learning about is called same side interior Again, they're formed the same way. So formed by two lines and a transversal. And there's something else we'll learn about them in a second. I actually just said it, gave it away, but we'll get to that point. Okay, so we just barely learned about interior and exterior. The last set of angles we talked about were alternate. They were on opposite sides of the transversal. This one has the name same side interior, so how is that going to be different? They're going to be on the same side of the transversal, right? So if we have angle 1, 2, 3, 4, then 2 and 3 would be same side interior. And then 5, 6, 7, 8, what's another pair of same side interiors? 6 and 7. And then if you want to do exteriors, you could. It would be 1 and 4 would be same side exterior. And 5 and 8 would be also same side exterior. Okay. If the lines are parallel, let's look at these angles for a minute. Angle 2, is it obtuse or acute? It looks acute to me. It's like smaller than 90, right? Look at angle 3, is it obtuse or acute? It's obtuse. So can an acute angle and an obtuse angle ever be congruent? No, that doesn't make sense. If one's less than 90, one's greater than 90, they can't be the same measurement. So instead of congruent this time, these have a different property. If the lines are parallel,
teachers, please excuse this interruption.
Same
Will you please excuse
side.
Madrigal students, Poly Choir, FBOs,
Interior
drill,
angles
cheer, dance, and all nominees to the auditorium.
are supplementary. If the lines are parallel, same side interior angles are supplementary. Now what does supplementary mean again? We've got a page in our book about that. They add up to 180. Just like adjacent angles do. So the measure of angle 2 plus the measure of angle 3 would equal 180.